Alright, so we're going to look at graphing inequalities, and it works just like when we were graphing lines. The only difference is we have to pay attention to the inequality, because that's going to change how this line's going to look. Otherwise, everything works pretty much the same. Here I have a positive 2 as my y-intercept. I'm still going to start my graph at positive 2. The slope here is 1/2. That means the slope is rise over run. It still works exactly the same. Still means I'm going to go up 1 since this is a positive 1 in the numerator. And I'm going to go to the right 2 since those are both positive numbers. So I'd go up 1 over 2, and that's where I'd put my first point. Then I'm going to go up 1 over 2. That's where I'd put the next point. I could keep doing that. But if it's an inequality, I've got to pay attention to this right here, this inequality. I got to pay attention to what it is. And this says greater than. Okay, it does not have a equal to. It doesn't have a line under it. So what that means is I'm going to make, instead of a solid line like we do when we normally graph, I'm going to make a dashed line. So when I graph this, it's not going to look like it used to look where we do that straight line all the way across. I'm not going to graph it like this anymore if it's just a regular old greater than. Okay, and the next thing I want to look for is if it's greater than, I'm going to have to shade this graph either above or below the y-intercept. Greater than would be shading above, so I would actually shade this graph above the y-intercept, which was positive 2. So greater than is always going to shade above, and if it was less than, I would have shaded below that line. All right, now here, very similar graph, just like the last time I looked for the y-intercept. This one's at positive 1. That's where I would start graphing. And my slope is positive 1/2. That means I'm going to go up 1 and right 2 because these are both positive numbers. Slope is rise over run. It's telling me to go upright, so I'm going to go up 1 over 1, 2. And that's where I'm going to put that first dot right here. Up 1 over 2, up 1 over 2. And this one's different because this is a less than or equal to. If I'm looking at this inequality right here, less than or equal to, if it has a line under it, that means when I go to graph this, I'm actually going to use a solid line. So I'm not going to use the dash line like we did before. This graph is going to have a solid line. Okay, because of this line under it, if it's equal to, all right, it's going to look very similar to just a regular equation that we've graphed before. But now I have to also go back and look at what this inequality tells me. It says less than. If it's less than or equal to, or just a regular old less than, I'm going to shade underneath the y-intercept. So our y-intercept was right here. I'm going to shade underneath that. Okay, so where I shade depends on what the inequality is. This one was less than, I shaded under. The other was greater than, and we shaded up here above the line. So depending on the graph, the inequality, that tells me where I'm going to shade. And it tells me if I'm going to have a dashed line. If it does not have an equal to, it's a dashed line. If it has an equal to, like this one did, it's going to be a solid line. All right, so now this one is less than or equal to negative 2. Okay, so I've got this graph where it doesn't have a slope. It's just telling me that y is less than or equal to negative 2. Usually we have a slope and a y-intercept. This one just tells me the y-intercept. So I'm going to graph this, and it's just going to create a horizontal line, just like when we talked about with linear functions. If I'm graphing them, I find negative 2 because all this inequality has is a y-intercept. So y-intercept is right here. It does not have a slope, so it's not going to go up and over like we've been doing. It's just going to be a horizontal line that goes across here. And because this is less than or equal to, it's going to be a solid line going horizontally like we talked about before. If it doesn't have a slope, just like the floor you're standing on, if it's a level surface, it does not have an incline. It doesn't have a slope. So this is just going to cross the y-axis. If it says y and it does not have a slope, it's going to cross the y-axis. Okay, at that point. Now it would still shade according to the inequality. This is less than less than is always shade below. Okay, so wherever the y-intercept is, I would shade below that depending on what the inequality is, and this was a less than, so we shade underneath. And you'll also see graphs that just give us the x. This graph here says x is less than or equal to -4. Well, where is x on the x-axis? Where is -4? Well, it's right here. So what this is doing is it's kind of doing the opposite of that other graph. The other one gave us a y-intercept. This one is giving us an x-intercept, and it's saying -4. And since that is less than or equal to, this line is going to be solid, but it's going to cross the x-axis this time. Okay. Now earlier we looked at one where it crossed the y-axis because it said y is less than or equal to -2. This one says x is less than or equal to -4. If it's just an x, it's going to cross the x-axis. Okay, so we're crossing the x-axis at a specific point, and now I would shade just like kind of on a number line this time. Less is always going to be to the left. So just like when we had those number lines and we were shading depending on what the inequality says here, I'm going to shade to the left because it's less than, which x values are less than or equal to -4. So it's a solid line, and I shade to the left. Right, and that is how we are going to be doing graphing with linear inequalities.